because that wouldn't make any sense.
Well, we had
Um,
Mr. 83 on here, so I guess it could be.
yeah, just call me Paul. That's fine.
Welcome to the Create and Invent podcast. As always, we've got my co-host Pat Regan here, and then we have somebody new who's Mr. 4-Bits, also known as Paul. How are you doing, Paul?
I'm doing just fine, Jeremy.
And
Wonderful
He
to
was
join you.
born Mr. 4-Bits, and
changes.
that was too complicated, so now he's known as Paul.
Yeah. Now Paul's been on
Paul
here
for short.
I don't remember it was what episode, maybe 61, maybe I don't really know. We were on a live
I don't
stream.
know. It was a long time ago.
Had some good conversation. But yeah, so Paul is actually somebody I know in real life. So that's kind of a change for this episode because I've actually met Paul, and it's interesting talking to you online now because I talked to you decent amount in person. Anyway, Paul, why don't you tell us a bit about your background? I mean, I know you grew up in Tampa, went to, can I say, Tampa Prep?
Yeah, I actually did not attend Tampa Prep. I stayed in the public schools. I did teach for Tampa Prep later.
Okay.
I taught high school for 11 years. I think 6 of those were at Tampa Prep. Which I have a lot of connections to, but I'm not actually a graduate from there.
I'm going to be careful what I say if you're connected, Paul.
Yeah, I am a connected guy.
So now you're your education is mathematics it's physics, correct?
Yeah, no, I have an undergraduate degree in mathematics and a graduate degree in computer science.
Okay, and your teaching was you taught mathematics at Tampa Prep or other school as well.
I taught mathematics, I taught physics, I taught computer science, and at some of my other jobs, I taught robotics.
Okay, very nice. So you have a lot of experience.
Yeah, I was a pretty versatile teacher for the people I worked for.
Nice. Yeah, that's very cool.
Yeah.
Yeah. Now, Paul. Part of the reason, I guess we'll just get this out of the way here. Part of the reason we're having Paul on today is because, Pat was telling me he was thinking he might want to take some time off. I guess is that right, Pat? Am I?
Sure, we could go with that. That's a good summary. I like that.
Yeah. So Pat's gonna be. I don't want to say stepping away, but I guess that's accurate to say. Maybe he'll be back, maybe
wander
not.
Off? Can I wander off?
He'll be wandering around for a while, and I don't want to say his replacement, but Paul has graciously volunteered to come in, help us interview some people. He's got some great background knowledge on a lot of different things. Mathematics and computer science is obviously his forte.
And electronics.
At
an amateur level.
Yeah.
I've long had an interest in electronics since I was a boy, and I'm happy to have time to put into that now.
Well, one thing I wanted to ask you about, what I think is interesting about your background is, you went from mathematics to computer science, and you've pretty much learned electronics by yourself. But I guess my thinking about that is if you're teaching high school level calculus and whatever, if you really, really, really understand the mathematics, it's like you've learned the language, and then you're just kind of reading it. It just probably makes sense. Is that correct?
Boy, you said it. I mean, knowing as much math as I do, I have not encountered any mathematics and electronics that is intimidating in the least. And that's partially the mathematics background, although a lot of the math I studied was pretty abstract, but also just taking honors physics in college. Between those two, and knowing all of the E&M with calculus, yeah, it's much easier to read documentation, application notes, etc., and get up to speed on things really quickly. So, yeah.
Nice. What do you mean by E&M? What do you?
Electricity and magnetism.
Oh, okay. Now, in physics, though, they do things a little bit different than the electrical engineers do. Is that correct? Was that ever a problem?
It's not all that different. I mean, in any basic physics course, if they're doing electricity, you're going to learn all the basic circuit stuff. But knowing certain bits of theory, like we proved that in a charged spherical shell, the electrostatic force anywhere inside the shell is zero, which is like a pretty consequential result. And, it seems like a lot of hard calculus at the time. And honestly, once you've proven it, you're never going to prove it again. But just having those concepts down, it helps. And just the raw mathematics of it. I mean, once you have a good grasp of calculus and you have a good grasp of what all the units mean, like what is a volt?
Yeah, no, that's true. You break that down, you do the unit analysis on stuff, and I feel like that's maybe one of the most important things in engineering is being able to figure out what the units mean and whatever. Because I think you take all these classes, knowing the units and knowing how to work with that is maybe one of the most fundamental things in engineering. I feel like, and correct me if I'm wrong here, Paul, but I think at some level engineering is kind of all the same. It's the concepts are the same, but then you kind of branch out a way of thinking that I think translates between maybe disciplines in some ways. I don't know.
Sure. In terms of reading equations, doing the dimensional analysis with the units, like you were saying, understanding which values are derivatives or integrals of other values, that's a general skill that crosses disciplines for sure.
Oh yeah, for sure. So now just thinking about your background a little, you went to University of Chicago, is that correct?
I did.
Okay. And is that where you
That's
did
where I got my math degree.
Okay.
And believe it or not, I was a computer science major up until the fall of my senior year.
Wow.
That's when I switched to mathematics.
I didn't know
I switched to mathematics because somebody put a roadblock in front of me, and I was only one credit away from a math major, so I just went ahead and switched departments and finished that out.
Wow.
So I was one credit shy of being a computer science major. Computer programming was like so much easier to get into in the early 90s, late 80s than electronics was. I had the basic electronics hobby kits and I'd wire them up and stuff like that, but a hand-me-down computer was all you needed to program. When you think about test gear, like we as adults, I mean, we don't think that much of test gear.
Are you calling me an adult?
Yes, I think so. I mean, if you can afford a $200 meter, then I think you're an adult. Teenagers can't really afford that. My grandfather gave me I had two hand-me-down multimeters. That's all I had as a kid. I had
now
one.
You get a passable multimeter for $12 on eBay or something.
Oh, it's true.
Yeah, or free at Harbor Freight, right? Although that might
I wish I had. Yeah, well, these like the first one I got was a 1950 big metal block meter. Yeah, analog meter. It's huge. Had very weird batteries in it. Those old timey batteries before everything was standardized.
I'm picturing a lantern battery for some reason.
Yeah, me
but
too.
I know
Actually,
it wasn't that big.
Yeah, no, it was probably like one of those rectangular paper-clad batteries with a bizarre voltage nobody uses now. And so I still have it. I want to restore it. But that was my first multimeter, was this 1950 jobby. And then my grandpa, sometime in probably the late 80s, bought me a Micronta analog meter from Radio Shack.
Okay.
So analog meters were all I had until well after college. Like getting a digital high impedance meter was something I only was able to do once I got back into electronics after all my schooling. So
when did you get back into electronics? I mean, did you do this as a teacher, or did you kind of do that to develop that as a hobby a little later, or what happened?
So
there?
some as a teacher. So I was still teaching when I got into electronics. And started buying used test gear and playing with Arduinos and stuff like that. And I actually got comfortable enough with it that I was able to put together an electronics class that I only taught for one semester before I quit teaching.
This is at a high
Um,
school level, correct?
yeah, high school level. So these were high school juniors and seniors, and we learned how to program Arduinos, how to read data sheets, and hook up LEDs and switches and basic stuff like that.
What did they think about that? What did the kids? What was the response from the kids?
Oh, I think they liked it. It's so hands-on in a way that they hadn't experienced before. Um, everything's very virtual for these kids, and
And
that's the way it was for me when I got
roughly
into
what year was this
programming.
when you were teaching this class?
Oh, let's see. That would be around 2012.
Okay.
I was teaching this
All right. So you're
class.
saying
Yeah.
even at that time things were just so virtual for the kids that was a little different.
Well, yeah. I mean, for me in the 90s, like I was saying, get my hands on all the physical stuff. Like, there's never been an easier time, I think, to get into electronics. Like, you and I both submit orders to, PCB fabs and get our PCBs within like a week. That didn't exist in the 90s. Like, it was so expensive to get PCBs and it was slow. Um, I mean, you're probably spending $1,000 to get a prototype PCB, and then
Oh,
the expectation is you're going to make 100,000 of whatever you're making, right? And
yeah.
so this small time prototyping stuff was just not as simple. You could make your own boards. Uh, my grandfather would do that because my grandfather was he was an electronics engineer. He was a radio engineer. Um,
Grandpa 4 bits. What
yeah,
was it?
Grandpa 4 bits. But he, so you could etch your own PCBs. That was pretty much the only way to do it. But they were big and clunky and nothing like the nice PCBs we can just order online today.
Oh yeah.
I mean, the
You know what
convenience, the ease.
I got this. You mentioned this. I got this PCB from PCBWay actually. It's assembled, and it was like it took them like 2 weeks, a little over just over
Yeah,
2 weeks to get it here from China. That's what's shipping, and I think that's like
yeah.
shorter than usual, but it's still.
Still, I mean, that was just unimaginable when we were
It's
kids,
hard to
you
imagine
know?
even now, to be
And we
to
had
be
nothing
honest.
like an Arduino in the 90s.
No,
Not
I
even
mean,
close.
yeah. So, like, the fact that you can, I mean, the thing that makes the Arduino so accessible, I think, is just the fact that you can plug it into USB, right? The fact
Mm-hmm.
that you don't have to buy a $300 programmer in order to program the chip is like everything, right?
It was nice.
Because in the past, when you had to buy a programmer and you had to buy the programming environment because there weren't free tools out there, like it was a big hurdle to get into this stuff. So, um, yeah, yeah, it's. I mean, there's never been a better time to get into electronics as a hobby, I think. And so I was happy to get back into it after years of doing very theoretical, very virtual stuff. And so I think that's a very good thing for kids. And it doesn't have to be electronics, it can be wood shop or whatever it is. But to have to interact with things physically and build physical objects that either work or don't work, they either succeed or fail. There's no like fudging it or making it look like it works when it doesn't.
Well,
Like that's valuable. That's valuable, I think.
so you did that for several years, and now you're I mean, I guess your profession is you take care of your kids, but then the other thing, you but in addition to that, you also run 4-bit Industries, correct? That's your, I guess, business,
Right.
correct?
So I kind of do three things. I teach at the Tampa Hackerspace occasionally, which is good. They appreciate that. Um, I make these learn to solder kits that are behind me, and I sell them at 4bitindustries.com. Um, and then the other thing I do is people contact me wanting contract work, programming microcontrollers or putting together, advising them on putting together systems or actually putting them together and installing them, doing a bit of programming, and so I do kind of contract work on top of it.
Okay. Do you find the contract work is more profitable? What do you find more profitable, is forbidden industries or the contract work?
Oh, definitely the contract work.
Okay. You,
Seriously.
yeah, no, I believe
I
you.
mean,
And I'm honestly,
like,
I might have known the question. I might have known the answer since I know you
might have
well.
known the answer already. Oh, and also I should mention that I write some. I still write microcontroller reviews for Make Magazine,
Oh, that's right.
um, but at a very slow rate.
Right.
So that slipped my mind for the time being. Although I do have a new microcontroller I'm going to write a review for.
Nice.
Yeah, no, definitely the contract work, because you can. I mean, just think about what you can charge per hour. I mean, I would never
Yeah, but you
charge.
only have 40 of those hours every week.
Well, it's true. You only have 40 of those hours every week, but the time it takes me to put together kits, I mean, just the time it takes to order parts and then intake them and sort them, like the return on that time is nowhere near the time I can charge, the price I can charge per hour for professionally programming.
Yeah. Well, that makes sense for sure. I mean, it's
Yeah. I would say if I had more of the work being done by third parties and was, I don't know, paying somebody minimum wage to deal with packaging and shipping this stuff, and I was actually selling them in volume, then yeah, maybe selling kits would be more profitable. But I really don't sell that many of them. I'm really grateful for things like custom orders. Like I have a school that orders 50 kits from me with a custom PCB with their logo on it. They order them every year. That's great. I mean, that's because you think about the time you spend dealing with the customer, packaging things up. It's much smaller per unit when you're dealing with a bulk order, right? So bulk orders are great. It's the little one at a time orders that take a significant amount of time, and I can't charge as much for it.
well, I mean, Pat and I have talked about this as far as like the big orders. It's like, he seems to encourage me like, yeah, you need to give a big discount for like lots of stuff because you're not, getting up off the couch to, you're doing it one time rather than say like five times. And that's absolutely true. I mean, I don't know. I think hopefully I've followed your advice somewhat, Pat.
Well, I hope I had good advice. I
Yeah.
don't even know if I remember giving this advice, but I believe you.
Well, I don't know
Sounds
that.
like something
No,
I'd
I
say.
I don't know that.
oh, I tell people if they're ordering 20 or more, email me and I'll give you a quote based on where prices are right now. And I will, because I'm probably going to have to order parts for a big order. I'm just going to go ahead and I'm going to price it all out and I'll give them the best price I can.
Right.
Uh,
Do you ever
but
look
See,
at
as soon as I see contact me for a quote, I go to the next spot because I'm not contacting anybody.
so Paul,
I'm ready. I just want to hit order and I want my stuff.
have you ever
Yeah.
looked at working with a distributor or anything like that?
I have not. Like, I have insurance for my business, and I know as soon as I get distribution, I'm going to have to change my insurance. They're going to charge me more.
Hmm.
Um, and I don't know. I'm constantly on the fence between either putting a lot more time into it and trying to make it really successful, or giving it up and shutting it down. This is the thing about being in sort of the maker economy. Um, it gives you a lot of independence. You get to work on what you want to work on. Like I get to design whatever product I want to design next. I mean, there's a lot to be happy about there. At the same time, uh, you're taking on a lot of risk, right? If I just go get a regular job, a regular 9 to 5, that's a pretty low risk proposition for me because I know I'm getting a regular paycheck and I know that they will give me regular work to do. Um, I like having very flexible time right now. That really works for me, but I don't know. I don't know that this is a forever thing.
Right. No, that makes sense. Um, that being said, last time you were on here, your office didn't look that organized, but today you seem to have a pretty fancy set of shelves there behind your head. So what's up with that? I see you've got some nice boxes
I
too.
do. So I bought a bunch of IKEA shelves. I stained them. I put my box organizer system up there, and yeah, everything is much, much better organized. Um,
Nice.
yeah. No, I have some thoughts on organization.
Well,
I
let's
could
hear it.
probably make a
What's your number one tip for
you want to hear it?
office organization?
All right. So um, I think I came up somewhere in one of my notebooks because I keep paper notebooks with my ideas in them. I came up with the three principles of decluttering. One, think trash. Okay. The only sure way to get rid of clutter is to get rid of it permanently, right? Number two, putting things in containers makes them larger, not smaller.
Hmm.
And that's just physics. If you put things in containers, they will take up more room than they did before. And what's the third rule? I'd have to look it up.
They're very important rules, especially the
Yeah,
first two.
yeah. The first two are extremely important.
Well,
The first rule is the third rule might be touch it once. I'm gonna say that's the third rule. That's usually my rule of moving and packing. Touch it once. It means you can organize and reorganize things forever, right? But if everything you pick up, you say, I'm going to deal with this now, this is either going in the trash or in the recycle bin, or it's going on a shelf, and you do it for every single thing you pick up, then you will make progress on decluttering. If you decide you're going to group things first, well, you can group things and regroup things and never actually get anything
hmm.
dealt with. So the result of that is that I love number one, using vertical space.
Yeah.
So these shelves are really tall. I have high ceilings in here, so these shelves go super tall. Um,
And the stuff that my wife doesn't need go on the top shelf because she can't get up there. She's very
absolutely.
small.
Yes, that works fine. But yeah, use your vertical space because horizontal space is always at a premium. Answering the question of how to minimize packaging size, because like I said, if you put something in a container, it gets bigger. So, like, here's my resistor. Oh, no, this is my capacitor box. A lot of people like to organize things in drawers. I hate that. I hate these organizers. I have one here.
Some
Hold on a
strong
second.
language there, Paul.
People like these drawers.
Oh yeah,
I
so
hate
you got
them.
the
I don't
clear
like them.
drawers
I
there.
have one over here. I don't like them.
Yeah. Like, if I put 10 resistors in here, this is a huge amount of space that's wasted. That's all air in there, right? But if I keep it in a plastic bag, a little Ziploc baggie, I can squish that flat. I can put like 100 of them in one of these little cardboard bins, and it just takes up a lot less space. So
Right. I mean, so just describing what you have there for the audience, it looks like, I mean, it looks like almost like two by fours, but you said it's from IKEA. Basically, just
it is.
It
these
looks like a bookshelf,
like,
Jeremy.
well,
That's
yeah,
what that's called.
like a bookshelf, but instead of books, he has these
Yeah.
cardboard bins that have little plastic bags inside. So basically, you can stack them like tiny little filing folders, except instead of papers inside, he's got resistors, capacitors, and whatever else he needs for his latest build. I guess is that accurate?
Yep.
Okay.
Yeah, that's pretty much it.
Okay.
And yeah, I mean, I really fill these boxes up, and it's worked. It's worked really well. And people say, oh, well, then you have to go through your resistors like a card catalog to find the resistor you want. Rather than having them in an array, you can just grab the bin you want. You know, it's like that has never slowed me down at all, mostly because about 90% of the resistor values you have in that array, you're never going to use, right? What am I
It's true.
constantly going for? I'm going for the 10Ks, I'm going for the 220s. I actually have like 4 resistor values that I try and use in all my designs, right? And they're at the front of the bin. I can find them very, very quickly. So,
Nice.
um, yeah, efficiency is the name of the game here.
Oh yeah, for sure. So, I mean, for me, I've got a bin system, but I've got a little closet in my office. So actually, a pretty nice closet. So that works out pretty well. I can just kind of hide stuff back there. Do you guys want to take a coffee break when we come back and maybe talk a little more about Paul's background
I
stuff?
would love a coffee break, Jeremy.
Yeah. All right. Well, we'll see you in a second. All right, Pat. Well, welcome to the coffee break. Yeah, I guess you got your coffee. So the buttermilk coffee. So I guess as we do every episode, shall we go ahead and read off our top 5 or so patrons?
I will count them with my fingers like I try to do every time.
Okay. So first we got Timothy Moran. Hello, Carl. I saw you the other day. You said you say hi to me. I say hi to you every 3 episodes or so. So hello, Michael Sizer.
Quarterly.
Yeah, quarterly. That's right. Raptor, creatively spelled, Brian Moses, and of course, Positive Waves waving on by. We appreciate all of your sponsorship. That's awesome. Now, if somebody did want to support us on Patreon, what would they do, Pat?
Oh, they could go to patreon.com/createinvent, all one word.
Nice.
But Jeremy, they don't have to pay us monies on Patreon.
They don't.
You don't have to. We appreciate, like, if you hit likes and thumbs up and subscribes and things in the various places where this video or audio shows up. Because it shows up in, common places, sketchy places, skeevy places. You never know where it's going to be. But wherever you hit a thumbs up, we're going to be excited about it.
Well, that's true. And you know what else would be excited about, right, Pat?
Oh, no, I don't.
All right, so if you want to leave us a message and do a time-delayed live call-in, you can go to speakpipe.com/create-invent. So you just go there and press start recording, and you can say whatever you want to us. And we may play it on there, or we may not. But yeah, if you got questions, comments, whatever, you just want to say your name. Say, hey, I'm whatever. That's fine.
It's true. You could go there on your phone to the web if you have a smartphone.
Yeah,
like I'm sure most of you do because almost everybody does now.
Most of you, yeah. You can use
talk at us.
You can use your burner if you want, But yeah, if you want to just have,
we won't know is the bummer. I'd be excited to. You can tell me it's your burner, and I'll be excited.
Just tell us that, and if you don't want us to play it, we can do that too. Just let us know. So, yeah, either way.
Yep.
But yeah,
we could play it. We could say your name. We could not say your name. Whatever you want. We're going to assume that if you leave us your name though, and you don't tell us, don't tell anybody. Then
it's gonna be public.
We'll call you out. So,
yeah. All right. Well, yeah. With that, why don't we get everybody back to our show? So.
Oh, is that the right song?
It might be.
Yeah. That sounds right.
Why not?